Today we're going to discuss chapter 3.1, graphing linear equations. So we want to start with looking at the standard form of a linear equation. Keep in mind what you know about the word linear, right? Particularly the first four letters of that word, because it's an equation of a line. So any equation that can be written in this form forms a line. And so the idea is that there is a number in front of the x, which we're going to call a. There's a number in front of the y, which we're going to call b. And there's a number on the other side of the equal sign that we're going to call c. Also remember that a, b, and c can either be positive or negative. So let's take a look at one possible equation. And so y equals 4 minus 3x. And so the question is this a linear equation? And what we need to do is get this into the proper form. So we need to get the x and the y on the same side. They'll be on the left side. And the numbers that are standing alone are going to go on the right side. So the first thing I want to do is add 3x to both sides. And when I do that, this will cancel out. Negative 3x plus 3x cancels out. And then over here I have y plus 3x. Keep in mind this is not 3xy. This is just 3x plus y. Sorry, it should be a plus. Equals, and then this 4 is coming down. So I got 3x plus y equals 4. At this point, I now have it in the form ax plus by equals c, because I have a, which is my 3, times x, plus, remember there is a number in front of that y. It's a 1, so my b is a 1. So I got 1y equals, and then this is my c. So this is a, my b is the 1, that's the c. Here's my a. All right. Now, if you take a look, next thing we want to talk about is x and y intercepts. So if you think about, if you're looking at a graph, the intercept is where does it cross the x and the y-axis. So this is my y-axis, and of course it's crossing at this point. It's my x-axis, and it's crossing at this point. Now keep in mind that x at the y-axis has a value of 0. So this is 0, 30. And then down here, remember that y on the x-axis has a value of 0. So this is 2, 0. So my x-intercept, where it crosses the x-axis, is at 2, and the y-intercept, where it crosses the y-axis, is at 30. All right, to keep in mind that this is a point on a graph, but if we're just talking about the intercept, the x-intercept is 2, the y-intercept is 30. Now, if we want to try to do this using algebra, there's a way that we can solve or find the x and y intercept of an equation without having to actually create the graph. Because as you can imagine, finding the graph of this might take some time. I would have to substitute numbers in for x and substitute numbers in for y that would make this statement true, so they would equal 16. And then, so for example, I could put like a 2 in here and a 1 in here. I'm sorry. Like a 4 in here and a 2 in here. So this would be 2 times 4 is 8. 4 times 2 is 8, so 8 plus 8 is 16. So I could graph that point, 4, 2. And I would have to find a bunch of those points. I would have to graph them, and I would have to figure out where it crosses the x and y axis. So my graph would look something like this, and then I could find the 2 points. But that's going to be very time consuming. So the idea is that what I can do to find the x-intercept, all I have to do is put a value of 0 in for y, because at the x-intercept, where this line will cross the x-axis, the value of y will be 0. So this becomes 2x plus 4 times 0 equals 16. Now I know that 4 times 0 is going to be 0, so this ends up becoming 2x plus 0, but I don't have to write that, equals 16. I'm going to divide both sides by 2. And then x is going to be 8. So my x-intercept is going to happen at 8. Now to find the y-intercept, I'm going to do just the opposite. I know that the value of x at the y-intercept is 0, so I'm going to go 2 times 0 plus 4y equals 16. Now I know that 2 times 0 is 0, so I don't even have to write that. This is going to become 4y equals 16. I'm going to divide both sides by 4, and I got y equals 4. So my x-intercept is happening at 8, and my y-intercept is happening at 4. And I don't necessarily have to create a graph to find it. All right, well, thank you very much for watching this video. Don't forget to do the problems at the bottom of the page. I'll see you in class.